So the problem statement, like I've already discussed, there will be a 2D grid and value 0 represents empty cell, 1 means fresh orange, 2 means rotten orange. So we need to return the time required to convert all the fresh orange to a rotten orange, and we can move in 4 directions from a cell location. So we will be using BFS algorithm, and we will be applying BFS from the location having cell value 2, so that we can convert its adjacent location from value 1 to 2 if there exists any fresh orange in its adjacent location. So if we see this example, suppose this is the rotten orange. So in minute 1, this and this turned to rotten orange, because this was the fresh orange, it converted to rotten orange, that is value 2. Now in minute 2, like this is the adjacent cell locations, so we need to traverse this, so explore this cell location, and with this cell location we have converted this from fresh to rotten. Okay, from fresh to rotten, and then with this we have converted this one from fresh to rotten. So in minute 2 we got this. Okay, and similarly in minute 3, from this we can convert this to fresh to rotten, and in minute 4 we can convert fresh to rotten from this to this. Basically we are going to use queue data structure for the conversion purpose, and we are going to create our own structure. So I'll be creating my own struct, that is struct node, and inside this I'm going to pass the information that is required to represent this. Okay, so x comma y will be my cell location and t will be my timing. Okay, so I'll be creating constructor also. So the node, and it will contain what? Value x, y, and t. Okay, so I'll be using this pointer to initialize my value. Okay, so I've initialized it. Yeah, so I've created my own structure, and I've created the constructor in order to initialize this data members. Okay, next step will be to traverse this grid in, and to store the cell location having value 2 inside Q data structure. Okay, so we are going to perform simple BFS. I'll be creating Q data structure, and the type will be node start type. Okay, because we are going to store this node data type. So we'll be traversing this grid, and we are going to find the cell location having value as 2, which represents rotten orange. Okay, so yes, I'll be using this for loop. Yeah, so mm, I dot size and j plus plus. So I'll be putting the condition that if grid of I and j, if its value is 2, then what we need to do is that we need to enqueue the queue. Okay, so q dot push, we will be creating like we have created this struct node, our own data type. So we are going to push this inside queue. So it will be new node, and inside this I'm going to pass the initial value. So x comma y value will be I comma j, and initial time of all the nodes that I have enqueued is, it will be 0 initially. Okay, yeah, so I have enqueued all the cell location having value 2 and initialized its initial time equals to 0. Now I'll apply the same BFS approach like q dot empty. while not q dot empty. Okay, now after that what I need to do, I need to dequeue it. Okay, so as we know that it is of node start type, so q dot q dot front, it will give me the front value. And then after that what I will do is that I got the cell location, that is I comma j or x comma y, whatever. So from that I have four different directions. Either I can go up, down, left, and right. So I'll create an array. I'll be creating an array which will represent my four directions. Okay. So it will be suppose this cell location is I comma j, like uh, yeah, I comma j. So upper direction will be I minus 1 and j. So if we initialize this cell location as suppose coordinate system, like 0 comma 0. So from 0 comma 0 we can move in up location having minus 1 comma 0. So I'll put minus 1 and I'll be making my y. Okay, so minus 1 and 0, this is the up direction location. Now from this point, that is the value is 0 comma 0, I can move in left. So basically I'll represent it with 0 comma minus 1. So 0 comma minus 1. From this I can move in down, it means 1 comma 0. So x value will be 1 and y value will be 0. And from that I can move in right. So x value will be 0 and y value will be 1. So this is my four directions. Okay. Yeah. So node star n q dot front. Now, so this q dot front, what it will do, it will output the cell location having value 2. And from that we need to traverse in four different directions. So these are the directions. Okay. So direct four different direction I need to traverse. So basically I'll use this loop to represent the direction. Okay. So suppose R representing row and C represents column. Okay. So it will be like n of x plus, mm, suppose I'll be changing this variable name, plus x1 of I. Okay. And n of y plus y1 of I. So this is the new cell location, that is R comma C. Yeah. So we need to check like if first we need to check the condition, bounding condition. Like if R is greater than equals to 0 and R is less than uh, grid dot size, and same in case of column. Column is if column is greater than equals to 0 and column is less than uh, grid of R dot size. Okay. And that particular grid of R and C, if it is not equals to 0, or we can say if that grid of R comma R and C is equals to 1. So if this is the case, it means that we have got value 1 in adjacent location. So what we need to do is that we need to convert the value from 1 to 2 in that location, and we need to enqueue it in a queue. Queue dot push um, new node r comma c comma, so the time will be represented by this, and start t plus 1. We need to increase the time. For each conversion, unit time is required. Okay. But after this, what we need to do is that we need to uh, pop, because I have taken the front part of the queue, have popped it from the queue, like dequeue the value, and started traversing, exploring its four directions, and checking for the bounding conditions for the base case. And if I got adjacent value 1, I will change the value from 1 to 2, and I'll enqueue it again, but I'll increase the time by 1 because each conversion take unit time. Yeah. Okay. So I'll be making my result uh, value result. Okay. Yeah. So what I will do is that I'll store the final time in this result variable, which will be max of result comma n star t. Okay, so basically this will store the final result. Okay. Yeah. So finally, what I will do is that I'm going to check the new grid. So if that new grid contains fresh value 1, it means that there are still some fresh oranges left after performing conversions. So if it is, then we need to return -1. So if we got any fresh value, then what we need to do is that we need to return -1. Okay. Otherwise, we need to return what? We need to return result. Yeah. We can have a base case checking, like if grid dot size is 0, is 0, then return -1. Like not possible. If I run the code, oh my bad. Oh, I need to give a semicolon. Yeah, I'll submit. And yes, it has accepted. By this way, we can perform dot and orange problem.